let's look at this problem. Number one, consider the function. Now the function is given as function x is equal 5x to third. Okay. And you need to find out the critical point. Remember, to find the critical point of a function, you have to find the derivative. So what is the derivative of this function? F dash x. You bring the 2/3 down, 5 times 2/3, and you subtract 1 from the 2/3. 1 is 3/3, and that is minus 1/3. So it is x minus 1/3, and that is 10/3, and that is x minus 1/3, and that is 10/3 x 1/3. Okay, this is the derivative of that function. Now, in order to find the critical point, you have to equal the derivative to 0. So to find the critical point, f dash x equal to 0, which means that 10/3 x 1/3 equal to 0. The f dash x equal to 0, the critical point occurs, it never be 0, but it's undefined. This is an undefined function. It's undefined at x equal to 0, because you can see it here. If it is 0, it's going to be something over 0. It's undefined. So the critical point, it is x equal to 0. Now, determine if the critical point of fx are local maxima, local minima, or neither. Hence, this is a situation where only one of the two tests is actually applicable. Okay, let's use the first derivative. Okay, to determine that. If x or for x less than 0, if f dash x is less than 0. For x is smaller than 0, which is negative, which means f dash x is less than 0. Let's put this is negative. If you put this negative to the power of negative, it's still going to be negative at the end, because this is not an even number, it's an odd number, minus 1/3. So the function derivative of that function going to be less than 0, which means it's decreasing. The function is decreasing. For x greater than 0, then that function, if it's positive, then that function would be greater than 0. It's going to be increasing. F dash x is increasing. You could assume some stuff and look at it. Let's say if you have anything x less than 0, let's say it's 10. You could just go to your calculator. 10 over, let's say, 3 minus 1, which is less than 0, to the power minus 1/3. And you should look at the answer. The answer would be negative, which means it is decreasing. And you should also go to your calculator, put plus 1 to the power minus 1/3, and that's going to be increasing. Which is going to be positive, which means increasing. This function mean is increasing. Okay. When something decreases at x less than 0 and then increase at x greater than 0, which means that you have a local minimum. Okay, and that is local minimum at x equal to 0. Again, if it is less than 0, this is if you're going to go from less than 0 to 0, and this is from 0 to higher than 0. So it was decreasing first, see it's decreasing first, and then it's increasing. So this is local minimum. How about if it was increasing first from when x is less than 0, and then it is decreasing? That's going to be a local maximum. But that's not true here. Here it has a local minimum at x equal to 0. And that is the conclusion of this problem.